All right, so I think I've talked about these two slides, but let's just give it a review. So in the coastal environment, one of the main subjects is the need is to measure the bathymetry under the shallow water area, because you might be able to use a boat and sonar system to map the relatively deeper area where your boat can go, but anywhere between the edge and the land area, there will be a gap between the LiDAR data set and the other sonar data set. So therefore, in recent decades, there is also a development of the bathymetry LiDAR system. So for example, in this scanning, the one called scanning hydrographic operational airborne LiDAR survey system. So on this system, it had both near infrared and green band. So basically, the near infrared is band that typically when they use, in the urban area, they typically use this one. So in the water area, it will be mostly absorbed, and they may have certain amount of reflectance, which means that, for example, in the urban environment, sometimes there may be water bodies. So occasionally you will see some scattered spot on the water surface. So that could be from for example, boats or maybe sediment or other things in the water area. But you will see that near infrared would generally have that kind of phenomenon in the water area. The green LiDAR laser light, however, have much shorter wavelength, and they can penetrate a bit deeper into the water. So they have some absorption, but relatively less than the near infrared band. And some may be able to reach bottom. So it depends on what kind of situation. So the maximum penetration depth is around 60 meters or 2 to 3 times the Sachi depth. So the Sachi depth is basically, we talk about, we actually showed you one of the device, right? They have this kind of disc where it was painted into black and white chess mark color. So 2 or 3 times of that depth that you can see. So one Sachi depth is basically you drop that instrument into the water to the maximum where you can see it, and then 2 to 3 times of that. But anyway, so just understand that sometimes when we apply this kind of system to the coastal environment, let's say, for example, the Mississippi River system, usually you see a lot of water suspended sediment along with the river. So that can impact the visibility of the water. So how deep they are, you need to check your area, but maximum one they can provide up to 60 meters. So it was capable of collecting depth sounding on a 4-meter grid. So the resolution here is around 4 meters, depending on the altitude and speed. Horizontal accuracy is around 3 meters. Vertical positioning accuracy is around 15 centimeters. So the vertical accuracy is quite typical for all the airborne LiDAR system. Typically, the vertical accuracy is around 15 centimeters. Okay, but I'm kind of a little surprised about the horizontal accuracy. So that is really depends on the LiDAR system on board, the GPS system on board. So the airborne LiDAR bathymetry system, we're going to, so the goodness, the advantage of this kind of system is that it were able to measure the bathymetry under the shallow water where boats might not run around. For example, in our field trip that when we collaborate with some oceanographers, they do have some sonar system, but there's a gap, like the boat maybe around half-meter depth or so, the boat cannot further reach, and they can usually just, pointing downward. So there will be gap between that. And also another professor had a project with wax lake data, and they even fly the airborne LiDAR data set, and also had the sonar data set across the wax lake data area, but they have trouble to register both data set because of that gap issue. So these green band airborne, so basically airborne LiDAR bathymetry sensor, we're going to overcome this situation really well. And then also they can be applied to hazardous coastal areas because it's an active sensor. So it's not dependent on the weather or sunlight condition. And also it has excellent mobility for emergency response, because a lot of time when emergency happen, the weather condition may not be ideal for, for any of the satellite could possibly being blocked by heavy clouds. And also the sensor can map large area. Large area can be inventoried quickly, providing economic advantages. So nowadays, you see more of the application of these kind of sensors. That once they can afford it, you probably see more and more of data acquired by these kind of sensors.